When people hear NASA and Andromeda in the same sentence, panic spreads fast, but the real story might surprise you. For years, astronomers believed the universe spoke only in background noise, random static scattered across light years. Now, that silence has been broken again. And what NASA just revealed might be the beginning of something we were never prepared to face. Follow along, because sometimes, the truth behind a viral mystery is even more fascinating than the fiction. The truth about those viral headlines. Let's get real for a second. You've probably seen wild headlines about NASA emergency briefings, terrifying signals from distant galaxies, or cosmic distress calls hitting Earth. These stories spread like wildfire across social media and entertainment blogs. But here's where things get interesting. While those specific dramatic claims aren't verified by NASA or legitimate scientific sources, the universe is sending us genuinely mysterious signals that challenge everything we thought we knew about space. The difference between viral fiction and actual science matters, and today we're exploring what's really happening out there. NASA and astronomers worldwide are detecting phenomena so strange that they're rewriting textbooks, and you won't need exaggeration to find it absolutely mind-blowing. What is the Andromeda galaxy? Before we discuss any signals, let's talk about what Andromeda actually is. The Andromeda galaxy, officially called Messier 31 or M31, sits about 2.5 million light-years from Earth. That makes it our closest major galactic neighbor. On a clear, dark night away from city lights, you can actually see Andromeda with your naked eye as a faint smudge in the constellation that shares its name. This massive spiral galaxy contains roughly 1 trillion stars, similar to our Milky Way. Scientists estimate that Andromeda spans about 152,000 light-years across. To put that in perspective, if you could travel at the speed of light, it would take you 152,000 years just to cross from one side of Andromeda to the other. The scale is almost impossible to comprehend with our human minds. Andromeda has fascinated astronomers for centuries. Persian astronomer Abd al-Rahman al-Sufi first documented it in 964 CE, describing it as a small cloud in his Book of Fixed Stars. For over 1,000 years, people debated what this nebulous object actually was. Only in the 1920s did astronomer Edwin Hubble prove that Andromeda was an entirely separate galaxy, not just a cloud within our own Milky Way. NASA regularly studies Andromeda using various telescopes. In 2025, NASA released stunning new composite images combining data from multiple observatories including Chandra X-ray Observatory, Hubble Space Telescope, and Spitzer Space Telescope. These images help scientists understand galaxy structure, dark matter, and cosmic evolution. Andromeda will eventually collide with our Milky Way in about 4.5 billion years, though both galaxies will mostly pass through each other because the space between stars is so vast. Real space signals NASA detects. Now let's talk about the space signals that scientists actually receive and study. The universe constantly bombards Earth with electromagnetic radiation across the entire spectrum: radio waves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Most of these emissions come from natural cosmic processes like stars forming, black holes consuming matter, and galaxies colliding. NASA operates numerous telescopes and observatories specifically designed to detect and analyze these signals. The Chandra X-ray Observatory captures high-energy X-rays from extreme cosmic events. The James Webb Space Telescope observes in infrared, seeing through cosmic dust to examine the earliest galaxies. Radio telescope arrays like the Very Large Array in New Mexico detect radio waves from pulsars, quasars, and other phenomena. One category of signals that genuinely puzzles scientists is fast radio bursts, or FRBs. These are incredibly brief flashes of radio waves lasting just milliseconds, but they release as much energy as our sun emits in an entire day. Astronomers first detected an FRB in 2007, and since then, specialized telescopes have found thousands more. The Canadian Hydrogen Intensity Mapping Experiment, or CHIME, has been particularly successful at spotting these mysterious bursts. What makes FRBs fascinating is that scientists still debate their origins. Some bursts happen once and never repeat. Others pulse regularly from the same location. In February 2024, astronomers detected FRB 20240209A, which produced 21 additional pulses through July. Researchers traced it to an ancient galaxy 2 billion light-years away where no new stars are forming. This discovery surprised scientists because they expected FRBs to come from young, active stellar environments. The famous WOW signal mystery. If we're discussing mysterious space signals, we must mention the legendary WOW signal. On August 15, 1977, astronomer Jerry Ehrman was reviewing data from the Big Ear radio telescope at Ohio State University as part of a SETI project searching for extraterrestrial intelligence. He spotted a signal so strong and unusual that he circled it on the printout and wrote WOW in the margin. That excited notation gave the signal its name. The WOW signal lasted 72 seconds and came from the direction of the constellation Sagittarius. What made it remarkable was its frequency, 1420 MHz, the exact wavelength that hydrogen atoms naturally emit. Scientists consider this frequency special because hydrogen is the most abundant element in the universe, making it a logical choice for any civilization trying to communicate across interstellar distances. For almost 50 years, the WOW signal remained one of astronomy's greatest mysteries. Researchers tried repeatedly to detect it again, but it never reappeared. Some speculated it might be evidence of extraterrestrial technology. Others suggested natural explanations like comets, though those theories had problems explaining all the signal's characteristics. Recent research in 2024 by the WOW at Home project provided new insights. Scientists analyzed data from the Arecibo telescope and found similar but fainter signals caused by activity in interstellar clouds of cold hydrogen. They suggest the original WOW signal might have resulted from a sudden brightening of hydrogen emissions, possibly triggered by a magnetar flare or other powerful transient radiation source. While this doesn't definitively solve the mystery, it offers the most plausible natural explanation yet. Magnetars and their bizarre behavior. To understand many mysterious space signals, we need to talk about magnetars. These are a special type of neutron star with magnetic fields so powerful they defy easy description. A magnetar's magnetic field can be 1 trillion times stronger than Earth's. If a magnetar existed at the distance of the Moon, it could erase every credit card on Earth and potentially disrupt our cellular structure. Magnetars form when massive stars explode as supernovas, leaving behind incredibly dense cores. These stellar remnants pack more mass than our entire Sun into a sphere only about 20 kilometers across. A single teaspoon of magnetar material would weigh as much as a mountain. The intense gravity and rapid rotation create electromagnetic fields of unimaginable strength. These extreme objects occasionally produce what scientists call magnetar flares, sudden releases of enormous energy that can outshine entire galaxies for brief moments. In February 2024, NASA's NUSTAR and NICER X-ray telescopes observed a magnetar right before and after it produced a fast radio burst. This observation provided crucial evidence linking some FRBs to magnetar activity, though it doesn't explain all of them. Magnetars might also explain other mysterious phenomena. The repeating radio signals that pulse every few seconds or minutes could come from magnetars spinning with precise regularity. When charged particles interact with these powerful magnetic fields, they can accelerate to incredible speeds and produce radio waves that sweep across space like a cosmic lighthouse beam. When satellites become the mystery. Sometimes the source of mysterious signals isn't billions of light-years away but orbiting right above our heads. In June 2024, astronomers at the ASCAP radio telescope in Australia detected a powerful radio signal that momentarily outshone everything else in the sky. At first, they thought they'd discovered an exotic nearby object. The excitement was palpable as they analyzed the data. However, the image created by the telescope appeared blurry, which confused the researchers. After careful investigation, they realized the signal came from the near field of the antenna, not from deep space. Eventually, they traced it to NASA's Relay 2 satellite, which launched in 1964 and stopped working in 1967. This dead satellite had been orbiting Earth as space junk for over 57 years when it suddenly emitted a strong radio signal. This discovery raises important questions about space debris and orbital safety. We currently have over 22,000 satellites in orbit, and only about half still function. Dead satellites have collided hundreds of times over the decades, creating millions of fragments traveling at speeds up to 18,000 miles per hour. If defunct satellites can spontaneously emit signals, they might interfere with astronomical observations or confuse monitoring systems. In October 2025, another satellite signal mystery emerged. Amateur satellite tracker Scott Tilley accidentally discovered that SpaceX's classified Starshield network was transmitting on frequencies normally reserved for sending commands up to satellites, not receiving data from them. He detected signals from 170 Starshield satellites in a frequency range where nothing should be transmitting downward. This unusual behavior potentially violates international telecommunications standards. Fast radio bursts that changed everything. Let's dive deeper into fast radio bursts because they represent one of astronomy's most active research areas. The first FRB ever detected, called the Lorimer burst after its discoverer Duncan Lorimer, was found in 2007 but actually occurred in 2001. Researchers were analyzing archival data from the Parkes Radio Telescope in Australia when they spotted this millisecond flash from 3 billion light-years away. 4 years, many scientists remained skeptical that FRBs were real astronomical phenomena. Some wondered if they might be equipment glitches or terrestrial interference. That skepticism vanished as more telescopes detected more bursts. The Canadian CHIME telescope has been particularly productive, detecting thousands of FRBs since it began operations in 2020. This flood of data transformed FRBs from mysterious oddities into a legitimate field of study. What makes FRBs so intriguing is their variety. Some burst once and disappear forever. Others repeat with seemingly random timing. A few pulse with remarkable regularity. FRB 20220610A, detected in June 2022, was 4 times more energetic than any other FRB observed. Researchers traced it to a galaxy 8 billion light-years away, making it one of the most distant FRBs ever pinpointed. The repeating FRB 20240209A mentioned earlier comes from the edge of an 11.3 billion-year-old galaxy where star formation ceased long ago. This challenges theories that FRBs only originate from young stellar environments. Meanwhile, other FRBs come from active regions near magnetars. This diversity suggests multiple mechanisms might produce similar-looking signals, like how different instruments can play the same musical note.